Part 3, vector application problem. So the one equation we need to know for this whole section is right here. Vector representation of a line. As always, it's given your formula sheet. And all you gotta really understand is how to use this. So when you see this, R is just like the point xy, the position xy. A is the initial point. T is time or whatever variable you want. And B is, here's the important one, it's the velocity vector. Slash directional vector. So that one's not a point, it's a vector. It's very important. Alright, so I give you a vector here, A, B, and we're going from A to B. This is my initial point. B is not the B there though. My B here would be the vector AB. Right, because it's that's the velocity vector, that's where you're going. So A would be, this would be my A in that equation. My B would not be that B, it would be the vector AB. Okay, now let's apply this with this equation, with this example right here. So find the vector equation. So when you see that, you're going to write this down. Now we just got to find the initial point and the velocity vector. So it passes through a point A, A34, and B17. So you could do it any way you want. We'll say A is my initial point. You can make B your initial point if you really want to. We'll say B is over here, 17. So we're gonna have it go this way. It doesn't. You can have it go the other way if you want. It just changes your initial point. So in this case, my initial point right here, A, would be the A right there, 34. Now my B, like I was trying to stress earlier, B is not 17. B is the vector AB. Remember the way we find vector AB? Tip minus tail. So we're going to do B minus A to find that. So 17 minus 34, it's a bad 17. Subtract -2 and 3. And that's the B vector. So over here I'm going to plus T -2, 3 equals xy, and that's the velocity vector. So again, right, your initial point is A, so that's my A right there. Your B is not the point B, it's not the second point, it's the direction it's going. So you got to find the velocity vector for that. So you just do tip minus tail, and you get that. And that's it. Now let's do some examples where I give you the vector equation of a line, and we gotta apply it to solve some problems. So like this one here. Each of the following vector equations represents the path of a moving object. T is measured in seconds, and T is greater than 0. Distance units are in meters. Find for the object the initial position, the velocity vector, speed, and position at 2 seconds. Right, so some of these are really easy. Initial position we know. It's just in that formula, R equals A plus TB. Initial position is just A. Your velocity vector also very simple, it's just the B. Speed we haven't talked about yet. All speed is the magnitude of your velocity vector. So it's just the magnitude of the velocity vector. So very simple. And then find position after 2 seconds. Well, all you do there is plug in 2 for T. That's kind of the gist. So here, for example A here, right? So this is in a vector equation form, right? Where it says R equals A plus TB. So for question 1, initial position, that's just this part. Initial position is the point to -3. Notice I wrote it as a point, now it's a vector. For the second question, velocity vector, well, that's this thing. So my velocity vector, now it's a vector. So I'm going to write it as a vector in that cool, slick, vertical format. 4, 3. Alright, so velocity vector is just the velocity vector, just the one next to the T. Right, your initial position is the one by itself. The speed. So for number 3, the speed, right, it's just the magnitude of the velocity vector. So I got to find the magnitude, using the magnitude formula, which we've been using, of the velocity vector of this thing. So remember, the magnitude formula is this. A squared plus B squared. So 4 squared plus 3 squared, which equals 16 plus 9, which is radical 25, which is 5. And then finally, the position after 2 seconds. So all we're going to do is go to our velocity vector and plug in 2. So go back to that equation. xy equals 2, negative 3, plus 2, we plugged in 2 there, 4, 3. And the way you simplify that is very simple. You just distribute and add. So we're going to get our 2 right here. T equals 2. Distribute into both of these. So we're going to get 2, negative 3, plus 8 and 6. Add them up, and you get 10 and 3. So after 2 seconds, it's at the point 10, 3. That's how easy that one is. Let's do another example like this. So down here, the first thing you should notice is that this is in a very different form than the last one. This is called a parametric form. Now, something to be scared of. Parametric form is actually very simple. So if we scroll back up here, parametric form is just the vector equation forms broken up. So like, see, if you break this up and just look at the x's, that t would get distributed to both of them, by the way. It would be x equals 2 plus 4t. And look at the y's. Y would be negative 3 plus 3t. So that's the vector equation in parametric form. So using the same concept, you could go down here, back to the problem we were doing, and put that in vector equation form. Right, so right now the x is like this, and the y is like this. So if I want to put that in vector equation form, it's going to be xy equals, you put the constant first, that's your initial point, right? So the one without the variable right here is your initial point. So in this case, that's 4 and 0, because y has nothing there, plus t, and the stuff with the variables, the coefficients of the variables there. So right there, that's in vector form, vector equation form. Once you have that, the rest of the stuff should be fairly straightforward. Initial position, well, that's the A. So my initial position is the point 4, 0. That's where that vector starts. The velocity vector, well, that's the B. So my velocity vector is 2, negative 3. The speed, like we talked about last time, that's the magnitude of the velocity vector. So we just use the magnitude formula on this one. So that's going to be square root of 2 squared plus negative 3 squared, which is 4 plus 9, or radical 13. And then the position after 2 seconds, just plug that in for t. So it'll be 4, 0 plus 2 times 2, negative 3. Distribute that 2 to both of them. And you get like that. Add them up. 8, negative 6. Right? So that's how you do this if it's given to you in parametric form. First write it in vector form, and then good to go. Okay, let's do the last type of vector problem we're going to see in the summer assignment. Find the intersection of two vector equations. So when you find an intersection of two things, in any case in mathematics, it's always the same thing. If two things are intersecting and you want to find where they intersect, you set them equal to each other. This is always true. So if two things are intersecting, you set them equal to each other, and that's the way you're going to solve them. And the same thing is here for these vectors. So I have this vector equation right here, this R1. I have this vector equation over here, R2. I want to figure out where they intersect, so I'm just going to set them equal to each other. I'm going to set this part of this vector equation equal to that part of that vector equation. So I'm going to get this. Negative 2, 1, 1 plus S 3, 2, 4 equals R2, which is 15, ignore the smudge over there, plus t negative 415. So now the way you solve it, then we're going to separate these. So now we have this equation equals that equation. Looks kind of scary. There's like 2 3 by 3s on each side. All you do is you put them in parametric form. So like separate the top line. That's my best try doing that. Negative 2 plus 3s, right? That s should be all of them, equals 15 plus negative 4t. The same thing. The t goes to all of them. The middle line, 1 plus 2s equals 5 plus t, 1 times t. And then the third line, 1 plus 4s equals 3 plus 5t. So now if you look at this, you have 3 equations, but only 2 unknowns, s and t. And so how do you solve this? Well, you use elimination or substitution, back to algebra 1 skills. So what you do is pick any 2 equations you want. I'll pick the top 2 here. And I'm just going to solve it by elimination. So negative 2 plus 3s equals 15 plus negative 4t. And I got 1 plus 2s equals 5 plus t. So again, I'm going to solve this by elimination. So I'm going to try to cancel out one of the terms. I'm going to try to cancel out the t right here, because it's really easy. I'm going to multiply the whole bottom row by 4. That way the t's could cancel out. So I'm going to get this. 4 plus 8s equals 20, right? 4 times 5 plus 4t. I really should put the 4 on both sides, but whatever, you get the point. And over there is negative 2 plus 3s equals 15 minus 4t. And we're going to add these up. It's like solving normal two equations to unknowns. Add down, negative 2 plus 4 is 2, 3s plus 8s is 11s, 5 plus 20 is 35, and then these cancel out. So then I'm going to solve this, solve for s, subtract 2 from both sides. 11s equals 33, so divide by 11, s equals 3. So s equals 3. I'm not done. Some people, you could go back and plug your s in to find other t, but you don't need to. Most of the time, you do not need to solve for other t. Only need to solve, only, double important, need to solve for one variable. Because the question isn't find the variable, it's find where they intersect. So we're not done yet, actually. We gotta do one more step. And that final step is plug that variable you found, could have been s or t, sub it back into its equation to find out where it hits the other vector. So the s equation is the one right here. Right, here's the equation with an s in it. So I'll plug my s, my 3 into there. And then I'll get the final answer. I'll figure out where they intersect. So let me do that down here. So it's xyz equals, I think, 112, negative 211, plus 3, right? That's what we found, times 324. And like always, you just simplify this. Distribute that 3 to all of it. We get negative 211 plus 9, 6, 12. Add up like terms. Add up the corresponding parts, I should say. 7, 7, 13. So that's the intersection of the points. So again, the way you do it, all you have to do here is set them equal to each other. Right? Because I'm finding intersections, you set them equal to each other. Once you do that, you separate them. Then you pick any two you want to solve and solve by elimination or substitution. Once you find one variable, unless they ask you to find both variables, you just got to find one. And once you find one of them, you plug it back into its equation and simplify, and that's how you find the intersection. That's it.